will basically change this any word. We need to just here write a name of any word. So for example, you can have any word and then you can give path of that word, or either you can just give here robox in the find, and then in robox we have some word here. You can just give the warehouse, or you can give the default path actually. Well, and when you go to launch this, actually the same file here again, you're gonna see the warehouse word in the end. So because it is written in SDF, it's complaining about some version, but you can safely ignore that, and then you're gonna see something like this in the end. So here is our drone actually. It's very dark here, but well, yeah, that's how you can change the word actually. You can name any word which is available in the gazebo. Okay, actually you have seen that we don't have sensors, required sensor for the obstacle avoidance and mapping environment, so we need to customize a little bit. So the official way is to actually doing it by Jinja. Jinja is the template language that could create the SDF, and we should change the Jinja itself, but for a quick fix we can actually change. Here's are some different kind of models in this directory of px4. So we're gonna go here. So this is the depth camera, iris depth camera. The name of this is iris depth camera. What we need is to just copy this code here. I can very quickly add here Lidar. Well, the model name is Lidar. Lidar should be available here, and then include pose. It's okay. Then I can create another joint here, Control C. Officially you should actually say that adding Lidar sensor, Lidar joint here. So well, I can paste this again here, Lidar joint. I can name it. If this is revolting, I can say revolt, otherwise it can fix. But well, here is the Lidar. Link is the child and the parent is the iris based link. Okay, we need to see that if the link name is right or not. For example, I can go here. Okay, name is the link and model name is Lidar, so we can write Lidar link here. Base link, pose, inertia, and everything is defined there. I can just save this for now, and I can copy the name here, iris depth camera .SDF, and I can come here, and in the vehicle I can say here iris depth camera, and SDF they already included here in the argument. Let's see what's happened. Well, great. We need to change the basic model of iris a little bit because it is without sensor. We need to add some sensor in it. So if we see here what I have done, this is the main file of iris SDF. SDF is the official file for gazebo simulation actually, SDF, and here actually we can, if I go to line 370 something, after all the joints here I have added the depth camera. Actually for depth camera I have added the file from here, depth camera file, which look like something here like this one here. So it's describe the camera. Here we can change the pose. I have written 0.025, which because the inertia is and the gazebo unit of measurement is meter. So if I want to write centimeter, I can write 0.025 centimeter high in z-axis. Yes, and this camera has mesh of white box actually already defined somewhere here in the iris real sense camera. So this one here, and if I click on here, actually this is the mesh actually. So yeah, this is the actual mesh written. So these are the pixel actually. This is the white color, whatever. So based on this depth camera, we have first we have this file. We have given this URI. This please, we are saying okay, please pick up this depth camera file and give the pose of this to here. And after that, we are saying that please give a name of joint here. The name of joint is type is revolved. It's okay, so camera can see revolve actually. So this is the child link, this is the parent link, this is the main file, this is the depth camera file name there in the end. So we have given some more, and similarly we have added this lidar here. This is lidar basic file actually. We have given the pose. We have given the 5 centimeter and 13 centimeter x and z axis because it's centered around 0 0, and if I give plus 5 centimeter, it's just coming into towards the camera, and 13 centimeter high means it's above the camera because we have decided 0.025 like 2.5 centimeter, and mesh is a little bit high. And if we write 0.0313 like 13 centimeter, then it should come upon the camera. So we have deliberately fixed the inertia in that in manner, so it doesn't affect the gravity and too much weight like mass, so that we can fly drone easily in the gazebo. But in real time, cameras and sensor have little weight on the drone, so that consume more battery. So here actually we are testing it in simulation. Okay, we can save this file here, can go here, and well, if we come here, we can say this is depth camera. Here you can see, well, you can see here depth camera, and here you can see a small sensor. Okay, it's gone, but there is a small sensor. I can run it again actually. It's taking a little bit of time, and then if I go here, it's consuming a lot of power actually. I can get topic list here. Well, we are getting some image capture here, some sensors data. Okay, somehow we can also see that this is the model. We can see we get camera, we get lidar, we get depth camera, lidar joint. And now you can see we have this gazebo board, which is okay. Here actually is the camera, and here is the laser sensor. You can see here lidar link. Right, so now we can just test it in the ROS and then start mapping. Later on, we can start building environment map and navigation stack on top of it. So these are the necessary steps. This is RP lidar. Yeah, so now we're gonna see actually that how it look like in ROS. Okay.